So the core argument of this paper is that an epidemiological approach to data commons benefits from a governance-centered model that mimics the way the web browser establishes application ecosystems. So this is specific to epidemiology, and we make that claim in argument by revisiting the principles of FAIR, findable, accessible, interoperable, and reproducible, and showing how in epidemiological studies the data governance very much drives the interpretation of these principles. So let's start with the architecture of the web browser application ecosystem. And one thing we found that is peculiar to this environment, arguably the most widely used computational platform in the planet, is the web browser. So it relies on an origin where persistent storage is shared across different paths. So the core demonstration in this report, which is illustrated in figure 3, there we are, figure 3, with two applications, is that we can acquire access credentials from one URL domain and share it with another URL domain with a different path. So same origin, different paths. The origin is what happens before the first /. So we'll have a SEER application here where an access API key is generated after logging in as a user, and then this information is shared with another application where we do not seek SEER API key certification. So these different applications, they populate an application ecosystem. So let's go straight to methods and look for those links. So these are the two applications, SEER key and cancer visualization, CAVs, and each of them is supported by an open source library, public open source in GitHub. So now let's start with the first demonstration, that we can share things across the persistent storage tier attached to the origin. So I'm going to pick this origin, github.com, and then my name here. So this is the domain for this application, whereas here we have the same origin, github.com, but now we have epiSphere as the path. These black boxes you see here is what you get by opening the developer tools. So if you go here, you see they close, and then now you can open them using the shortcut or retyping. So let's do it one more time. Make sure you know how to get there. So close, open, and remember you have the shortcut here. Depending on your machine, it may be a different combination of keys, and open. So what you see here is what's going on underneath the browser. There is a command terminal here. You can look at the application architecture here. You can look at the sources, what code is being used, and so on. So this is the browser has evolved to be a very complete environment. So let's go back to the application tier here. There we are. And let's have a little bit of a command line space here. So let's start with the demonstration that we can indeed write to a shared persistent layer across different applications. So again here, Jonas Almeida, here, epiSphere. So I'm going to start with the local storage, just reviewing very quickly what we have that we can share. We have an attribute value pair called local storage. Session storage is the same thing, but associated with the session. Then we have a very powerful and scalable asynchronous NoSQL backend here, and the more traditional relational backend. So it's funny that we're talking about backends within the browser, but that very much illustrates the mature level of development of web browser application ecosystem. So the browser has its own internal backend that can be used to share access credentials. All right, without further ado, let's do its local storage. I'm going to create a little string 123. So this should show up here, but it should also show up here. It should be a new key. That makes enough room to see. So if you pay attention to these two, you should see it show up. See, it shows up in both. And from the other one, we could do the same. And now 4, 5, 6, for example. And again, you'll see this number being updated here from this location. Okay, so let's go now to the applications. All right, so move to the method section. And let's start with the SEER key. Okay, so we have this one here, and the cancer visualization. We'll move it to the second browser. Okay, so the question is, can we go from here, SEER key, to here, cancer visualization? And remember, this is what's illustrated with 2 snapshots in figure 3. So as you go through SEER key application, you'll find out this is what's called an observable notebook. So you can find out this more by clicking on this link here. So we're going to explore access to NCI, surveillance epidemiology, and results, that SEER program, with shared credentials. So those credentials have to be generated after logging in the SEER resource. So if you go through the application, you find out that the key already is available here, and we could check. There it is. For instance, this key gives us access to 153 data schemas at SEER, and now I'm going to delete it, and you'll see it will disappear. Okay. So now if I try to remove, so if I now try to check it, we find out that SEER API key not valid, failed to fetch. Okay. So we have 1, 2, 3 steps here. 1, 2, 3. So let's do it. So this is where the API key is. And if you go there, you're invited to log in. There it is, hidden on the side here. Okay. And then in your account, you'll find your keys. So I'm going to copy this key, and I'm going to move it here. Before I paste it, it's important to see that if I now refresh this application, the SEER components will not work. See, SEER API key not found. So we're going to put the key here, and afterwards we'll try to find out where these keys are being stored. So I need to click enter to save. Notice at this point we don't have a key. When I click enter, this key is going to be saved in an attribute value pair store that is shared between the two, and now it's available here. So if you now reload, you'll find out that all the bits of the cancer visualization application are working. And you have here the example. Again, all of this is live. This is an observable notebook, so by clicking on the 3 dots, you can find out what exactly is underneath. So this is like an Jupyter notebook, but for the web environment, happens entirely on the client side, entirely within the browser. This is also true for the visualization. So you see the code for the visualization here. You can fork this. There it is. There it is. So you can fork the application to your own observable notebook. All right, now that we are here, let's just have a quick look at interaction. So you see here males and females. I chose melanoma with information that is being pulled directly from, there it is, melanoma, directly from CDC, and with explanations of the etiology that are pulled from SEER. And the applications are interactive because we have access to the API keys and we can retrieve the corresponding data. To see the data, you could, for instance, open this and find out this is for states and get individual values that are at its source. Again, none of this would work without the access credentials being shared between SEER and the cancer visualization of primarily CDC data. Okay, now what's left to show is how is the key being shared between the application, the SEER key application, and the cancer visualization application. So I'm going to use the shortcuts to open the DevTools on both sides. So what you'll find out is that instead of just one domain, now we have 2. The reason being that there's a web worker running underneath this application. So more serious applications would use shared persistent layers that are associated to the origins of web workers, internal web workers, not of the HTML containing application. So if you now go here you'll find out that there is the key, and same thing here. And again, if you write something at this level, so let's go to the web worker. So we're now at web worker level, and the same process should be available to us. So local storage, so this shows you lala equals to 1, 2, 3, and there it is, lala 1, 2, 3. Same thing here, and let's do it in reverse. Local storage, lala equals to 1, 2, 3, 4, 5, 6, for instance, and again we should see it updated on the other. Notice the communication is happening between persistent storage associated with web workers, not with the top application. Alright, and just showing you that this is true to define variables as it is to remove them. So delete, let's make sure we keep an eye on this one as well, and delete it from both. Alright, I'll stop here.